This video is created for educational and documentary purpose only. All narration, visual and descriptions are original and AI generated. This content does not promote violence or conflict and focus solely on aviation, technology, history and engineering innovation.
What if one ship could replace several others? Launch aircraft faster than ever before, generate more power than a small city, and quietly redefine how naval aviation works? No hype. No exaggeration. This is not just an aircraft carrier. This is a floating technological revolution. This is the USS Gerald R. Ford. The USS Gerald R. Ford is not an upgrade. It is a complete rethinking of what an aircraft carrier should be in the 21st century, built to replace the legendary Nimitz-class carriers. This ship represents the largest leap in naval carrier design in over 40 years. Every system, from power generation to aircraft launch, was redesigned from the ground up. The ship is named after Gerald R. Ford, the 38th President of the United States, and the only U.S. president to have served as a naval officer during World War II. This name reflects service, stability, and modernization, just like the ship itself. The USS Gerald R. Ford is among the largest warships ever built. Publicly known facts: nuclear-powered aircraft carrier, designed for long-term global deployment, built for efficiency, sustainability, and adaptability. But size alone is not its real strength. Technology is. At the heart of the ship are advanced nuclear reactors. These reactors provide virtually unlimited range, remove the need for traditional fuel logistics, generate massive electrical power. This excess power is not wasted. It supports advanced systems, future upgrades, and next-generation technologies. The Ford class is built not just for today, but for what comes. One of the biggest changes is emails. Older carriers use steam catapults. The Ford uses electromagnetic launch technology. Why does this matter? Because emails launches aircraft more smoothly, reduces stress on airframes, supports a wider range of aircraft, improves sortie generation rate. In simple terms, more launches, less wear, higher efficiency. Landing aircraft on a carrier is one of the hardest tasks in aviation. The Ford class introduces advanced arresting gear. This system adapts automatically to aircraft weight, reduces mechanical stress, improves safety, supports future aircraft designs. It's not just about catching planes, it's about doing it smarter. The flight deck of the USS Gerald R. Ford was redesigned for workflow efficiency. Changes include optimized aircraft movement paths, fewer personnel needed, reduced congestion, faster turnaround times. This allows the carrier to generate more sorties without increasing crew workload. Efficiency, almost endurance. Despite its advanced systems, the Ford class actually requires fewer sailors than previous carriers. Why? Because automation replaces manual processes. Digital systems reduce redundancy. Maintenance is streamlined. This results in lower long-term operating costs, better living conditions, improved safety. Modern carriers are not about manpower alone. They're about smart manpower. Life at sea is demanding. The USS Gerald R. Ford improves crew living spaces, medical facilities, training environments. These changes may seem small, but over long deployments they matter. A better supported crew means a more effective ship. The ship uses modern radar systems designed to provide improved tracking, better situational awareness, reduced maintenance. Details remain classified, but the focus is clear. See more, maintain less, operate smarter. The world has changed. Threats evolve, technology advances, logistics become complex. The USS Gerald R. Ford was designed to remain relevant for decades, adapt to new aircraft, support future systems, reduce lifetime costs. It is not a response to one threat. It is preparation for uncertainty. An aircraft carrier is not defined by its size. It is defined by what it can launch, recover, and sustain. The USS Gerald R. Ford was built with one clear priority: efficient air operations. Every improvement on the ship ultimately supports this goal. One of the most important metrics for a carrier is its sortie rate, the number of aircraft missions it can launch and recover. Publicly stated goals for the Ford class include higher sortie generation than Nimitz-class carriers, faster aircraft turnaround, reduced maintenance downtime. This is achieved not by rushing crews, but by redesigning how the ship works. Efficiency replaces brute force. The USS Gerald R was designed to support current carrier-based aircraft, future manned aircraft, unmanned and autonomous platforms. Its launch and recovery systems are flexible enough to handle a wide range of aircraft weights and designs. This future-proofing ensures the ship remains relevant for decades to come. Aircraft maintenance is one of the most demanding aspects of carrier life. The Ford class introduces better maintenance access, improved logistics flow, advanced monitoring systems. By detecting issues earlier, the ship reduces downtime and improves readiness. Preventive maintenance is always cheaper than emergency repair. The USS Gerald R is often described as a digital warship. This does not mean automation replaces sailors. It means technology supports decision-making. Digital systems assist with equipment monitoring, resource management, operational planning. This reduces human error and improves long-term reliability. One of the most forward-looking aspects of the Ford class is its massive electrical capacity. This power surplus allows for advanced sensors, future defensive technologies, systems not yet publicly revealed. The ship was designed with growth margins, ensuring it can integrate new technologies without major structural changes. While details remain classified, it is publicly known that the ship focuses on layered awareness, early detection, integrated ship defense. The emphasis is on survivability, not aggressive posturing. Protection is about preparation. The USS Gerald R never operates alone. It is the center of a carrier strike group, working alongside escort ships, submarines, aircraft, support vessels. This networked approach allows the carrier to project presence without isolation, strength through coordination,